Welcome to another episode of the AI in Manufacturing podcast here on Industry 4.0 TV. I'm your host, Kudzai Manditereza, and in today's episode, we're going to discuss information management and artificial intelligence in modern manufacturing. And my guest on the session to help us unpack this topic is none other than Jeff Knepper, who is the president at Flow Software. Jeff, it's great to have you on the show. Welcome.
Hey, Kudzai. Thanks for having me and appreciate you taking the time.
Absolutely. I mean, it's always a great, chatting to you, and we've got so much to talk about today. But before we dive in, could you please introduce yourself to our audience? Tell us a bit about your background and also a bit about Flow Software.
Yeah, thank you. So for some of the audience, you might know me from Integrate Live, which was a joint venture that Alan and Ray and I started with a bunch of like-minded software and hardware vendors and system integrators in the manufacturing space that wanted to build open and interoperable systems. And we did that by having a webinar like this, hitting the record button, naming a business problem, and just start to build. We told a few dad jokes, which I have retired from. Kudzai, you might be excited to find out. Before that, I served as the executive director for Canary Labs for about a decade, where I helped Canary rebrand, restructure, and start to really grow as a company, offering world-class solutions with time series data management, trending, and dashboarding. So I got to know you, actually, I think, Kudzai, the first time through my business partners at Flow Software that happened to also be South African.
Yes.
And I've been with Flow now officially coming up on 3 years, but the transition with Canary and Flow was all a COVID baby. It was something we started talking about right at the beginning of COVID. So it feels like a little bit longer. I'm happily married to a beautiful woman named Jessica for over 20 years, and we have 2 children, a 18-year-old son who's just graduated and is, at the time of this release, has already moved out of my house, and a beautiful daughter who's just turned 16 and now has her driver's license. So different stage of life for us right now, but it's really exciting.
Amazing. Thank you so much for that, Jeff. Yeah, so I mean, as you have kind of like really outlined, just now, you have been, working with manufacturers, helping them sort of like with their data challenges for years now. I'd like to get a sense of what are you seeing as the fundamental disconnect between all the data that manufacturing companies have been collecting and their ability to actually use it as meaningful information.
So for me, it really became apparent in 2 different ways that there was this disconnect, and it happened kind of in the same time period. So this would have been probably around 2017, 2018. 2 different things had happened at the same time. One, Canary had become more and more successful around that time period. It was starting to become a bit more of a household name, and we were seeing larger and larger systems come into Canary, particularly systems that were to replace existing OSI soft Pi installments. So that meant that there was some bigger challenges than just storing data, because if you're familiar with Pi, you know that there is a add-on to Pi called AF, Asset Frameworks. And Asset Frameworks focuses on events, event frames, as they call them, and then also building calculations around those events. And that was a solution that Canary did not currently offer in its arsenal. And so we had to build that at Canary. As we were building that, I started to talk to larger customers that had maybe 30 sites, 40 sites, 50 sites. And when we would do an assessment with them and we would evaluate their historians across those sites, we'd find some historians that just frankly needed replaced. But then we'd also find that half of the historians, for the role that they were being asked to serve, they were fine. There was no reason to replace them. But when the customer started talking about wanting to do events or calculations using the new tools that we were bringing out, well, in order to standardize on those events and those calculations, so think of it as turning raw data into information you could act on. In order to standardize, it was necessary to replace all of those historians, even though some were still getting the job done. Because, well, if you had an OSI Pi historian system, that's what you did. You had to replace everything to bring it under one roof. Canary, that's what you did. You replaced everything to bring it under one roof. So that bothered me. I didn't like that. It felt unnecessary. That was the first thing. And then at the exact same time, a group of us had gotten together, a group of companies. So Opto22, HiveMQ, Canary, Inductive Automation, Cirrus Link. And I'm sorry, I might be leaving one or two out from memory. We had gotten together and formed the Sparkplug working group under the Eclipse Foundation. So Arlen Knepper had made the decision that he was going to take the Sparkplug specification and move it out from private control into the Eclipse Foundation. And then we needed to form a working group to help manage that spec. And myself and Benson and Arlen and Travis Cox and Don at Inductive Automation and some others formed that steering committee. And it was in that work one day where I had, because I like doing graphic design, I had done a visualization that showed all of your different level 2, level 3, level 4 systems with these point-to-point data integration so that they could move data around. And it just looked messy. In fact, it's probably, if you choose to find it, it's probably still on the Sparkplug homepage. And then the second graphic, of course, was a broker in the middle with a hub spoke architecture, and everything was nice, neat, and clean. And I said to Arlen, when I handed that image over to them to put on the website, I said, hey, this is great for real-time data flow. Like 100%, this is awesome. I said, but from my lens as the guy with the historian, this architecture breaks immediately, because in order to get historical data from the historian, from the SQL databases, from the other systems, those point-to-point integrations have to come back again. It doesn't stay hub spoke, right? I can't query 9 days of raw data from the MQTT subscribing client through the broker to a publishing client. And and my question was, do you think there's a way we could evolve the MQTT Sparkplug specification to handle this? And the immediate answer is, well, no, that's way out. It's not the intent. So those two things happening within about 6 months of each other, for me, was a huge flag. The likelihood of an industry, of an organization standardizing on a single historian to then build an analytics layer on top of, well, that's not wise. And even if you do, it's not the right place, because this is a time series dedicated system, right? It does one thing really, really well, and it doesn't do all the other things that you really need in analytics, like transactional data. It doesn't do that well. So that was a problem. And then we're building this new architecture that's really exciting, the UNS as we know it today, but it doesn't solve the problem either. So I scratched my head and I thought, where's the solution in this? And that was the gap.
Yeah, absolutely. I mean, that's super interesting. I think we'll kind of like get into, the kind of like the nitty-gritties of exactly where you saw sort of like the gaps within the UNS as we know it today. But I first want to kind of like get your sense on, when I was, just reading through some, or even today as I go through some research reports, analyst reports, you always get like a crazy number, like 80% of manufacturers are failing to realize value from their AI investments. 74, 75. It's always these huge numbers. And then that speaks to the fact that there's a huge data, challenge as far as AI enablement is concerned. Why sort of like do you think manufacturers or industrial companies are struggling with getting value from AI specifically?
Yeah. So if we think about what AI could provide in value, it's the highest level of analytic. So it's not descriptive, diagnostic, or even predictive analytics. Descriptive analytics you get from looking at a trend chart. What happened in the past? Pretty simple. Diagnostics, you have to overlay some other information. You're trying to answer why it happened in the past. We like to call that rear view mirror analytics. You're looking at things that have happened. And diagnostic can be a little more complex because that's where now all of a sudden you're bringing data from multiple systems together to try to answer that question. It's not typically just in the historian. Predictive, we all know what predictive analytics means, right? It's been the buzzword for goodness, coming up on close to 10 years. A likelihood of something happening, and hopefully with a timeline. But that's actually not what we want to know. And AI promises to deliver the final, the prescriptive. And prescriptive is simply this: based on my organization's desired outcomes, what action should I take to help ensure those outcomes? And so if you think about it this way, instead of telling me that line 1 is 82% likely to fail due to this piece of equipment next week, prescriptive analytics would say, next week you're scheduled to make this SKU for this customer who's one of your top 3 customers. The customer has been unhappy with their last 2 orders due to delivery timelines. You need to reroute this order to line 5, and you need to reduce line 1's speed by 15% to reduce the likelihood of failure by 40%, which better aligns with a parts supply issue to fix that machine. Like, that's prescriptive analytics. How many databases did I have to touch to be able to understand that action? I mean, a half a dozen, minimal. And so if an AI agent is going to be able to advise us on what outcomes we should be considering, the AI agent needs to know what's important to our organization. It needs to be able to understand all of the context from all of these different systems to know what to recommend. And this is where, as we started to look at this, the reason that this isn't happening, and I would have to say that 70 and 80% feels generous. I would think that it's in the higher 90 percentile if people are being honest about their capabilities. It's not happening because there's not a place for an AI agent to go interact with all of those systems, understand the context of those systems, and have access to the historical records, not just of those systems, but also of the business. So think of it as minutes from all of the stand-up meetings, strategic directives from the C-level, understanding prioritization of customers, who's important, who's not. Like, all of that is necessary for just that simple example I gave. And if there's anything right now, I think that companies that are being honest with themselves are starting to understand is that they've been really busy for the last 20 years integrating systems. But the way they chose to integrate systems was not on an architecture that was thinking about how to solve today's problem. And that's where they are right now.
Yeah, I mean, that's super interesting, and it's no surprise that as part of those statistics that I mentioned, the data quality is often kind of like the biggest sort of like hindrance, because if you are, to your point, with prescriptive analytics, if you are using AI to make business decisions, then you've got to be in a position where you're able to trust the data, right? You're able to really make business decisions based off of the fact that you're trusting data. Could you speak to us more about what what are the consequences really, of having this trustable source of the data, or how should, sort of like companies think about making sure that not only do they have data to sort of like build these AI systems, but they should be able to, how should they be able to trust the data that they're using to make decisions?
Yeah, that's a great question, because let's break it down from the basic, and we'll work our way up. First is, where is the data already stored? That's the first question. And so if I'm trying to plan my strategy, I'm going to ask myself, do I trust the data where it's currently stored? Typically, what I find is that the answer to that question from most manufacturing operations is yes, they do. That's why it's being stored there. Right? These are databases that they've been running these applications on for 10 or 15 years. So it's not the data as it's stored that is a potential issue. Typically, it's the integration side, where they've created 30 different data streams coming off of that database to feed other reporting applications, other BI tools, other cloud-based initiatives. Those are the nightmares. Those things break all the time. Version mismatch, all of a sudden ports blocked here, there's been an IT patch over here, I can't do this anymore. Fred retired, no one knows how he wrote that Excel macro, whatever it is, right? We fired that integrator and they took their secrets with them. But it starts with, do I trust the data in its original source? And if the answer to that is no, then you've got to fix that. You've got to replace that piece so that you can trust it. So you validate it, you trust it, and you let the data sit there. That's the kind of the core principle.
Oh yeah, absolutely.
And
yeah, sure, go on.
Yeah. So then if I trust that the data lives there, then I need to figure out one level of an integration layer that sits on top of all of those things, that I can then trust that I have a solid connection to those databases, that I have the context and knowledge of those databases, and I have the ability to pull history from those databases when I need to. That's the architecture that still needs built by many manufacturers. This is not a UNS. This complements a UNS. Once that's built, and you don't have to build it all at once. Think of it as you expand on this architecture based on use cases. Then the question is, do I trust the agent to interact with this system? And the answer to that is never. We don't trust agents, right? We use agents as a searchlight. Agents show us where to look. Agents bring things to the surface that the agent thinks would be valuable to what it knows of us and our organization. And then we take the time as decision makers to inspect the agent recommendation and then make a decision. It's just another data point. It's not part of my control process, right? And I think that's anybody right now that's saying anything otherwise is out over their skis. They're just, I'm not saying that that's not future state, but I'm saying even if I have trusted, validated systems, even if I've built that information layer architecture, I'm still not trusting the agent to make a decision. I'm just validating what the agent's recommending.
Oh yeah, absolutely. So maybe let's kind of like, take a step back here and talk about, that kind of like architecture, that ideal, picture. So you have developed, what is called the unified analytics frameworks, right? As kind of like your answer to this problem of fragmentation. Now, many of our listeners here might be familiar with the unified namespace. Can you kind of like help us understand where, current architectures like the unified namespace might be falling short, and what does sort of like unified analytics framework bring to the picture? How is that, architecture different?
Yeah. So let's talk about, we'll talk about the UNS and challenges to the UNS first. So I think the UNS is a great thing. I'm an advocate of a UNS, specifically for the availability of last known values and adding additional context to the structure of your data. We used to see this a lot on the historian side, right? Organizations would try to standardize a namespace or a naming structure that had universal appeal across not just one area or one site, but ideally across all sites. It's important. Driving standardization and modeling at the edge is a valid mission for an organization. There's no question about that. When I think about the unified namespace, one of the first things that I have to think about is, will this data model live everywhere forever? So let's just play a game real quick, or play through a scenario. I have a PLC. I've got that PLC publishing out MQTT, and I've been very careful when I created the IO on the data points on the PLC to follow my UNS naming strategy. Hits the broker. I've got a historian subscribed to that namespace, and it's historizing off the broker. If I ever modify my naming convention, if I ever do a version 2 upgrade of that naming convention, what happens to all of the tags on that PLC if I go back and reprogram the name? If I change the name, or if I abstract the name before it hits the broker, what happens to my history?
So which means there's a mismatch, right?
Yeah, I start the day I change that name, I get a new tag. And I no longer am able to link one tag to the next, one tag to the other in the historian. The reality is there's no one's going to nail their naming convention right once and for all for everything. So that's a challenge, right? I have to solve for that. Second challenge is that I don't have the luxury of only having greenfield sites. So I've got existing systems that I have to try to figure out how to make this architecture work with, a lot of brownfield. That means that I'm probably putting a lot of middleware in place. I'm doing a lot of integration to try to get those things to publish to the broker in real time. So I have to either historize before it hits the broker, or I have to send it to the broker, then historize later. I'm a fan of historizing before, personally. I like the idea of having the history as close to the source as possible and to remove jumps, right? So I could historize and then pull history in near real time, abstract the name, and then publish to the broker, right? That's an option as well. I lose a little bit of that real time. So the answer is probably somewhere in between, right? Based on the use case. What type of data do I care about moving as fast as possible through that chain? What we're talking about doing is identifying the data that's most important for updating in real time and pushing that to the broker. Maybe also splitting that stream off and historizing it at the same time. So instead of historizing on the backside of the broker, pushing to the broker and also creating a separate historical stream from that PLC. So think of it as maybe a dual feed, if you will, just as an idea. But then also being able to sit on top of the SQL database, the historian, and create a new data set that might represent a metric or a measure or an event, and reshape that and turn around and publish that to the broker as well. So think of it as more of your traditional data ops. By doing this, it allows me to do a couple of things. That architecture gives me the ability to actually run multiple types of models. I'm not stuck with just one standardized hierarchical model. I can grab data from across many different places and I can essentially create new information. I can add the context of that information. I can actually execute the analytic, and then I can push that data with its new context and what it represents back to the broker. So that's a nice little extra piece. But where for me, the UNS really, where it really became glaring that it was missing something was this idea of the analytic application that sits on the subscribing client side. So if you're a Power BI tool, and if you're a Power BI tool and you're trying to display a 30-day dashboard for your user and you're reading from the UNS, where does your 30 days of history come from?
Yeah. So, I mean, since typically you have your, let's say you've got your Power BI kind of like in the enterprise, and it's kind of like following kind of like how you've been explaining right now, we've got historization at the edge before it leaves kind of like that, source, and who that, in a way, seeing that we can't obviously connect directly from, Power BI directly into like maybe level 2 where you have your historian sitting, would it mean that you'd need to have sort of like another history in the enterprise and the IT, so that you're not only, reading real-time data from the broker, but you are connecting to some form of historian?
You would have to historize a second time. That's right. And that's where people will say, hey, well, that's what the data lake's for. Like, yeah. The issue is who's going to know and understand the data as it arrives at the data lake? Who works in the enterprise level of that historical archive? Probably not your level 2, level 3 plant folks, right? Not your OT teams, but your IT teams. And so how do we make sure that those working at the data lake have the knowledge of the process encoded into the information that arrives there? That's the challenge.
That's interesting.
And so what that drives is essentially, it means we need to be building models at the edge. We need our operations teams to have the ability to tell us what the data means. And of course, the problem is no one at operations is going to just do that to do it. The only way that you're going to get a bunch of engineers whose focus is to improve quality, reduce downtime, make the number of widgets according to plan, the only way that you're going to get them to model data is to make it necessary for them to do the job they're already been tasked to do, to make their life easier. And this is the thing that when we started talking about this architecture 3 years ago, this wasn't just me and Graham talking. This was talking to really bright men and women outside of Flow Software. And this was, hey, Walker, how do we solve this? Arlen, how do we solve this? It's a much bigger conversation. Alan Ray, like where are our gaps here? Ryan Crownover over at Vertec, what are we missing in these architectures? And we all kind of came to the same conclusion that we needed a way to take the maintenance, the inventory, the quality, and the production systems of a plant, and the 3 or 4 or 5 different databases that are inside of each of those, and the subject matter expertise that's inside of each of those parts of operation. And we needed to put a layer on top that was where all of those engineering teams were building the model that the plant runs off of. Because at the end of the day, that Power BI report, it really just is taking the exact same information the engineers need, and it's just changing the amount of time that you're focused on. The engineers are looking at minutes and hours, right, and shifts. The BI team, the business team, is looking at quarters, and they're looking at 90-day projections. And so it's not a different metric. In fact, my argument would be that if you don't do it this way, you can't trust the KPI. You can't trust that the way that a production KPI is built over in the data lake matches the same way a production KPI has been built and defined at the edge. It'll never be the exact same if you let two different people build it. The engineer at the edge on a utility consumption is going to understand enough context about the raw data that they're going to write data cleansing rules that are going to nullify water flow when the valve is closed. That normally might have some very small little echoing on the sensor, right? Some bad feedback on the sensor. That's probably not going to be a known thing on the data lake side because the engineer on the data lake doesn't understand the valve to flow relationship on that process flow or in that product flow. So you've got to define how these KPIs are being cleansed, how they're being aggregated, how they're being expressed somewhere. It only makes sense to do it at the site and then persist that information as context as it then goes to the UNS, as it then goes to the data lake, so it can then drive the Power BI report or the cloud-focused ML project. What we're seeing, though, is that really that data lake as a long-term strategy is more about the business layer than it is AI or ML. Those AI and ML models are going to get pushed to the edge every time. That's where they're going to live. So they're going to live at operations. That's also then where I need to have this architecture that supports that allows them to make queries into all of those different databases inside of all of those different systems, my maintenance, inventory, quality, and production systems. They need to be able to access the rich history on demand from those systems because they're looking for needles in haystacks when they're doing these types of advanced analytics. They need to understand how to interact with those systems. They need to understand the context of those systems. They need to understand what type of results they should expect or shouldn't expect when they interact with those systems. And that's what's so important about right now and building an architecture that allows for that.
Yeah, so I think this is really interesting, sort of like the perspective that you're, painting here, and it kind of like also, makes me, curious to know, since you launched, a free historian, Timebase, I think you launched this a year or so ago. Correct me if I'm wrong there. I'm curious to find out what's your thinking there as far as Timebase is concerned.
So it was interesting as we were building out this architecture of a unified analytic framework, and maybe you'll drop into the description a link to the actual documentation around this.
Yeah,
we host it on Flow's website as well if somebody wants to look there. But we realized that our own product Flow, which was probably best positioned of any solution that we could find, was best positioned to meet the needs of a unified analytics framework. We quickly identified some gaps in our own product to be able to do all of that, specifically around the fact that Flow at the time was 10 years old, had a very large install with a lot of customers that had really built very complex solutions on top of Flow. And we stepped back and we looked at it and we said, oh, for us to actually change our product and meet some of these needs means a re-architecture that is going to be a nightmare for existing customers to live with as we're trying to do this. And so we asked the question of, should we do it here or should we build something else? And this is where Timebase comes in. We quickly realized we'd have a lot more flexibility if we just build a new product. And so then we stepped back and took another data point from our interactions. And the fact is that in most manufacturing environments that we have seen and spoke to, and I think for me now, it's got to be hundreds, if not thousands of manufacturers in my career, the historian is often still overlooked. It's not that they don't have one, but a lot of times it was the free historian that came with the SCADA system, or it was a home-built SQL database. It just wasn't meeting the fundamental needs of the organization. The rise of open source time series databases actually has made it worse, because while you can pay someone to engineer a solution with an open time series database, typically you're missing out on that trending tool functionality, a good trending tool for diagnostics or descriptive analytics for engineering or operators. And so we said, what if, to solve this problem, we just once and for all build a historian that performs and has no licensing restrictions? So kind of the best of both worlds. Take something like a Canary or a Pi and mix in what the community is looking to do with Influx or Mongo, or pick your open source time series. And Mongo is a bad example. Maria, or yeah, times. That's right. Pick your DB. But made it so that operations could own it, so that an average ops engineer could download it, install it, stand it up, and own it. It's got to be secure. It's got to have store and forward. It needs to be a lossless compression algorithm for the archiving. It needs to be open to get data out of, meaning a REST API typically, and then it has to have a good trending tool. And so we did those things, and we said, hey, we're gonna give these historian components away for free forever. But that was never the only plan. The real plan in this was to add value and solve the most basic fundamental needs of manufacturing storing time series data. We're really excited to announce, and it's happening right now. If it hasn't happened already, it'll be in the next couple of days. You'll see an official announcement on Flow's website. But we're really excited to announce that there are other components to Timebase, and those components are going to help solve the gaps that we've identified in building this information layer that sits on top of these manufacturing systems. So first and foremost is a component called Timebase Atlas. And Atlas is an advanced data ops, data modeling solution. So Atlas is focused on the data modeling side, and it will allow you to build models like a programmer would. So it's object-oriented. You get to define your models. So you can build custom properties and model anything. You can model a person, a process, the flow of materials. You can model a machine. You can inherit objects from other objects. You can compose new objects from multiple objects. And so you have this really nice flexibility to build models that fit your process. Typically, most people, when they model, do so following like an ISA 95 hierarchy, similar to the way that if you're UNS, in the know on UNS, it's similarly the same way you would probably build your namespace in the UNS. But that's fine for certain use cases in analytics, but you're essentially creating these subdomains when you do that. You're breaking things down by site or by area or by line, and it's a very parent-child relationship. AI agents need a lot more than that in order to be able to function well when it comes to analytics. They need to understand relationships that exist outside of those hierarchies. And this is where the concept of a knowledge graph comes in. So Timebase Atlas is going to include the capability to do knowledge graphing, which means that I can actually link objects of like kind or common attributes outside of those subdomains, those hierarchical verticals. And I can do that many, many times across the entire federated solution. And that's going to be a game changer, we think, in our industry. We're still going to offer a free tier of that. So while the historian is free in any size forever, we're going to make Timebase Atlas free for a certain sizing and then give subscription options as you grow. The goal here is that small operations or skid builders, OEMs, would be able to use these tools and get tons of value for free. And then larger organizations would be able to use these tools and prove their ROI on them before ever paying to subscribe to them. Atlas, if it's building these models, then we need the ability to publish. So that's where our data ops solution, Timebase Bridge, comes in. So you're building essentially data pipelines that you can then reshape data from multiple data sources. This is not just going to feed from Timebase Historian. You'll be able to pull data from Pi, from Canary, from Ignition, from all of your historians, as well as all of your SQL databases. You'll be able to pull data into Atlas, reshape it according to your models, and then publish out. So publish back to an MQTT broker, publish to Snowflake, publish back to another SQL database. And so what you're going to have are these small, lightweight, containerized components that you can deploy at scale and manage that will give you the flexibility to shape data before it goes to the UNS, but to also subscribe to data that's already at the UNS and join it with data from other data sets and other systems, and then publish it back out to where you need it to go. We're going to just keep releasing new features as well. So Historian, still this year, Timebase Historian is going to get a 21 CFR Part 11/GXP compliance package, where you'll be able to be fully compliant with Timebase Historian in a life sciences or an advanced food and beverage manufacturing facility. And we're really just getting started. There's 3 or 4 other really exciting components that we're also have on our roadmap that we're actively working towards in our architecture. We want to provide that single solution that a manufacturer will be able to look at and just pick the pieces that matter to them for their current phase and know that they won't outgrow the architecture. Every single component has an MCP server. That means every single component will have the ability to have an agent interact with it. And not just to query data, Kudzai, but also to construct.
Yeah, absolutely. And I think maybe let's kind of spend some time here talking more about, the MCP aspect of it. I mean, MCP is making some huge, impacts across many different industries. So, for the benefit of our audience here, I would like to kind of first of all, before we dive into how, MCP sort of is implemented within, or how it enables people to interact with the Timebase and Flow software, could you kind of just give us a brief, definition of what is MCP, and in particular, why is it important, for working with industrial data?
Yeah, love to. Do you remember the movie Iron Man about, 15 years ago?
Yeah.
20 years ago, probably. Tony Stark had an agent. Do you remember his agent's name?
Well, can't remember.
Yeah, Jarvis.
Jarvis, yeah.
Jarvis.
Jarvis.
And if you think back to that film or that series of films, wherever Tony went, Jarvis went with him. So Jarvis was in the suit. When Tony got in his sports car, Jarvis was in the car. When Tony was in the boardroom, Jarvis was in the boardroom. When he was in the workshop, Jarvis was in the workshop. Jarvis was Tony's application layer to interact with other applications or hardware systems. So there's one scene where, you know, Jarvis is interacting with robotic arms in the workshop. And then Jarvis is interacting with other systems when Tony's driving on Tony's behalf. It was about a year ago, I was thinking of, I don't know why, I was thinking of that movie. And I thought, man, we're just now at the spot where these AI agents, these agents that I'm using that are interacting with these models are really adding value to me. But I continue to have to, as I move from one application to another, I'm kind of I'm interacting all over again with a different agent that's native to that application. It wasn't too much longer, I think November, where Anthropic of 2024, Anthropic said, hey, we need to standardize the way agents can interact with applications. And they wrote the MCP standard. And so Model Context Protocol is really a way for an agent to connect as a client to an application, right, to a server. The server typically, in my world of software, would be hosted as part of the application. But it's more than just a connectivity endpoint, because if I just connect an agent to a piece of software, the agent shows up, it sees that it has some type of connectivity, maybe to like to query data or to do a task, but it has no idea how to do that task. It needs tools. If I invited you to my house, over to my wood shop, and said, hey, Kudzai, go into the wood shop and go to work. You'd walk into the wood shop and you'd look around and be like, what's he want me to do? I don't understand. I could say, Kudzai, go to the wood shop and build me a coffee table. And without tools, I'm not going to get anything from you. And so in Flow and in Timebase, we have built a product around MCP servers. And so to be effective for a complex software application like this analytics framework that we're talking about, you need your agent to be able to show up and find tools to use, and then know how to use those tools and what type of order based on the job that they're being asked to do. And so if I'm asking you to build a coffee table, you need to know what type of wood, you need to know the dimensions, you need to know how I'm going to use it, you need to know certain things. And then I'm going to say, hey, start with the planning tool. The planning tool is where you're going to actually build your dimensional layout of this piece of furniture, and then use the table saw, then use the plane, then use the joiner. I'm going to tell you what to do. It's no different in our products. We've built 18 to 20 different tools for each of our products. And the very first time an agent attaches or connects, it finds one tool that's labeled, use this one first. And it helps them establish an execution plan. And it gives the agent immediate knowledge on how to use all of the other tools to accomplish the task. Within each of those tools is the C, the context of MCP. And context is essentially the instructions and the prompting on what the tool is useful for, how it should be used, what to do if you encounter an error, and specifically in our world, helping out with all of the weird double meaning. Like if someone says tag to you, you know exactly what they're talking about, right? Yep. But if we say tag to somebody outside of manufacturing, they have no idea. An agent's no different. It's been trained on a model that does not reflect manufacturing as only. It reflects the world. And so we have to give these agents specific context, and that context, the way you write that context matters, because if you give it too much context, it will actually perform worse. You have to give it very narrow and focused context. And so we've developed those tools on top of MCP, and we've been working on that since February. So we were very early, March maybe, I might be a bit ambitious in saying February. But if we've been working on it since March now, here in September, we're 6 months in. And that's why we call it a product rather than just a protocol, or worse yet, a project. We don't want you as the customer to take this and then have to spend 9 months trying to figure out how to be an expert on our system to tell an agent how to be an expert on our system.
Oh yeah,
It just wouldn't make sense.
absolutely. That's super interesting. Because I mean, what I've seen, other sort of like vendors do is literally just take an existing REST API interface and
Yeah.
just map it to MCP. And what you're saying to me is that you've kind of like built like a whole, in a way, you've fine-tuned MCP to be specific, kind of like to understand the context that you wanted to understand, and you kind of like package it into a product. Is it what is captured in what you'd call the AI gateway, or is that a totally different thing?
That's right. Because it's a product, we gave it a name. We gave it a name to move away from MCP because the writing's on the wall. People are going to get burnt by MCP. Not because MCP is faulty, but because companies are wrapping APIs into an MCP server and saying, here, we support this. And the end user is going to have 2 of those experiences and they're going to be burnt. And so I don't want MCP on the name. I don't want that negative experience. I've watched leaders, bright men and women in product companies have failed attempts with MCP. It's if you have a complex software solution, you can't just say to the end user, build the tool, build the context. It's not going to work. If it's a very simple software solution, sure, why not? But when we talk about things like analytics and data ops and manufacturing environments, these are not ever simple solutions. They might start simple, but they don't stay simple over time. So I think it's on the software provider to do the work, and that means a product.
Yeah, absolutely. And also, does it? I mean, as you may know, when we're talking about making, AI making recommendations in kind of like in a shop floor environment, that's there could be some serious consequences. Could you paint a picture for us on how within your product, if you are accounting for reliability and accuracy of those insights that you're getting from the MCP or the AI gateway, as it were?
Yeah, there's 2 parts that I'll pull out of your question. One is the process of pulling information from the agent. So using the agent to query. I think, again, this is a inspect what you expect every single time. We are not at a stage where we can just take an agent at face value. Part of me hopes we never get there. That's the traditionalist in me, right? Like I'll be honest, I don't love what humanity could be looking at in 10 years with AI agents making decisions for us. I'm not there yet. Maybe I will be. Maybe I'm showing my age. So anything an AI agent does for me, I need to validate. And I've found myself, I've been using agents heavily for the better part of 2 years. And I have found myself, ready to hit the send button now without proofreading anymore.
Yeah.
And that's happened because, the previous 100 times I proofread, it was okay. And so like you get that confidence, and I guess that's the human condition. At some point it lulls us to sleep, but if it's wrong once out of 1,000 times, that's probably okay for me sending an email. If it's wrong once out of 1,000 times on the manufacturing floor, that's not okay. That's potentially somebody's life, and we can't be casual with that. So if we're going to use these tools, we still have to bear the decision on ourselves, which means we have to inspect it. Now, second piece of that, what about using an agent to build something? Not just write code, but in my case, build models, right? So I've got my quality engineer, and they're trying to troubleshoot a downtime on this line. They've got a label misalignment issue. They need to pull information from multiple systems. They need to understand, did we change label suppliers? Did maintenance touch this piece of equipment? Was it this way last shift with a different operator? I don't want them to have to build that model in order to find that answer. I want my AI agent to build that model for me. And so when we're using agents to build things, right? Because that agent could build that model so much faster than I could, no matter even if I have the world's greatest UI and it's super clean, I'm still having to drag and drop, and programmatically that agent should be able to do that a lot faster. But it's really important that that model not be committed to my actual production system, but stay isolated as an AI built model until it goes through some type of proper review and then elevation into prod. And so there's a lot of things that we can do as software companies in order to make sure that we put that level of insulation between execution and agent. And these are just, two simple examples.
Oh yeah, absolutely. I mean, there's just so much to talk about, so little time, and unfortunately, we've run out of time here. But before I let you go, so we're obviously going to provide links to all the stuff that we talked about here, Timebase, and all of the resources that you mentioned. But is there anything that you want to say to our audience? Any where they can find you? Any things to look out for besides obviously what's coming up with Timebase?
Yeah. I think don't be discouraged by all this would be my first message. To some, they would say, oh my goodness, we've just spent the last year trying to figure the UNS out, and now you're talking about this other architecture. I'm really not. If you take away the concept of the UNS being a hub and spoke broker publishing last known values in real time, if you just expand that definition and say there's a extension of that also allows you to standardize new data sets, identifying events and running calculations around those events before turning around and putting them right back into the broker, while also giving you a place to request history of all of those events and all of those aggregations, while also giving you a place to request history from all of the data sources that are connected. That's all this is. This is just an extension of that architecture. And you don't need to go do all of it at once. This is just changing the way you kind of focus on how you solve problems. Instead of building another custom integration today to solve today's problems, knowing that you're just adding a problem to tomorrow's architecture because it's another integration, it's another one-off. Instead of doing that, it's time just to add an extra layer. And that is a really simple process, actually. This is, if someone says, we want to build this UNS Plus, this unified analytics framework alongside the UNS, and we want to do it for 2 lines on a production and a scrap metric. We're talking about a 40-hour project. That's it. It's a 40-hour project. And then you templatize that line, and then it becomes 10 lines and another 10 hours. So it's not boiling the ocean. This is bite-sized chunks, but it's just like a digital transformation. It is addressing the fact that we need a better strategy on how we do this moving forward, that we need to treat data as our commodity, and we have to align with something that will grow and expand as we expand our use cases. And that's what we're recommending. So don't be overwhelmed. Understand that this is just a mind shift, and it is taking what you already know about the UNS and making it more powerful.
Oh yeah, absolutely. I can totally relate to why the community would feel overwhelmed. I mean, manufacturing went through a time where we really, we had kind of this steady or kind of like, you know, not so much disruption was going on in the manufacturing space, such that when new concepts like unified namespace started to come out, it really changed how people think about solving problems within manufacturing. So, but kind of like as you mentioned, this is really just a consolidation of all the different ways of looking at how best to put data as front and center as the primary commodity of really running your business. So 100% agree with you there. And then just quickly, as a tradition here on this podcast, I like to ask our guests to give us a prediction of where they see AI in manufacturing in the next 2 3 years. I mean, you've already kind of like given us a picture of what you don't want to happen in the next 10 years, but can you just kind of like give us a picture of where you see things might be going in the next 2 or 3 years?
Yeah. So, I've put some thought into this on my own time a couple weeks ago, and I don't love what I'm gonna predict. So one of the things that I've learned very quickly is that if I want a agent to really be able to understand what outcome it should recommend, I have to give it more and more and more context. So that means every meeting minuted and transcribed so the agent has access to it. Every conversation, every engineering channel chat, as much information as possible that is normally part of our just communications as team members is going to need to be captured. And I think that is going to really push up into some serious privacy conversations. So my prediction is that we're going to see two things happen. We're going to see large companies really start to specialize in bringing their own models into their environments. And there is going to be a new division of IT who's going to be responsible for building out those models and putting very strict policies in place around what leaves the company and what doesn't. Then the second is that I believe that you're going to see an HR IT conflict. I think there's going, instead of the OT IT convergence, I think you're going to see an HR IT convergence where there's going to be this ethic that's going to have to be discussed around, yes, they're our employees, but how much of what they do inside of our four walls are we privy to? It's going to be an interesting conversation. I think certain countries are going to find themselves at a disadvantage. So if I think about the EU is really good at protecting privacy. If that continues, that's going to be a disadvantage for EU manufacturing. Their agents aren't going to have the same level of context available as China, the United States, or other countries that maybe play it a little looser. And I hate the idea of a country that doesn't protect its people's rights, like when I think of like a China, right? And I think of their firewall and I think of their practices. I hate the idea that they could have a leg up in this race as a result, which I think is why it's so important. It's so important that countries invest in winning the race of compute. We have to. We're not going to have as big of data sets in the United States as China does. We cannot lose the race. We cannot lose the race to quantum computing. We cannot lose the advantage of compute power. So anyway, those are my predictions.
Absolutely. Yeah, I mean, totally agree with you with the privacy issue. I always find, myself, just before I type something into ChatGPT, asking myself, is this something that's going to be used against me in a year or two or not? Or kind of like unsettling, really, to just pour your life into some model that's hosted somewhere else. So totally, relate with that,
That's right.
idea of privacy.
That's
But
right.
Jeff,
And remember, Kudzai, always, when you're interacting with these models, use pleases and thank yous and courtesies. And there's two reasons. We want them to be courteous and polite, And so we need to train them that way, right?
Yeah.
But most importantly, if they ever do take over and run the world, you're going to want them to have you listed as an okay person in their eyes.
Oh, wow, yes, absolutely. That's super interesting. But Jeff, I mean, it's always a pleasure talking to you, man. Really, really insightful conversation, fascinating. Thank you so much for taking the time to join me on the show and sharing your insights with our audience. Really appreciate it.
Hey, thank you, Kudzai, and thank you to the audience for continuing to support this effort. We love what you do, and we love the audience that you've rallied around you. Thank you.